Welcome back to Dashboard Chalkboard from Echoes and Footprints. Today's episode is called Math and Science, Acing the Test. In this episode, we'll revisit the two trains rhythm problem in a whole new way. Let's start with a problem you might remember from school. Two trains leave different cities. One travels at 60 miles per hour. The other travels at 40 miles per hour. They're moving toward the same crossing. When do they meet? Math teachers love problems like this. But what most of us didn't realize is that music teachers love them too. Because rhythm works the same way. Two patterns moving at different speeds, crossing at predictable points. This is called polyrhythm, and it's one of the most powerful musical ideas the African diaspora carried into the Americas. Today we're going to solve that rhythm problem, not with chalk and equations, but with the dashboard chalkboard. The two trains rhythm. Imagine two trains approaching a crossing. One train moves in 3 beats. The other moves in 2 beats. 3 steps, 2 steps. They start together, but they don't stay together. Their rhythms drift apart and then meet again. That pattern is called 3 against 2. Musicians write it like this, 3 to 2. You hear it everywhere once you recognize it. Clap 3 times. Now tap your foot twice. Suddenly, you're playing one of the most important rhythmic ideas in modern music. Here's where it comes from. Polyrhythm didn't begin on American highways. It traveled here through the African diaspora. Across West and Central Africa, musical traditions layered multiple rhythms simultaneously. One drum played a steady pulse. Another played accents. Another danced between them. The rhythms moved independently, but met at repeating points. Think of it like traffic patterns in a busy city intersection. Everything moving, yet everything organized. When enslaved Africans carried these rhythmic systems to the Americas, those patterns became embedded in work songs, ring shouts, spirituals, blues, gospel, later, jazz, soul, funk, hip-hop, and eventually, the music heard through dashboard radios across America. Now let's return to our dashboard chalkboard. Teenagers driving down highways in the 1950s and 60s weren't studying music theory. They were simply listening. But every time they heard rhythm and blues or soul music, they were hearing polyrhythms, backbeat on the snare, bass line moving underneath, vocals phrasing around the beat, multiple rhythmic trains crossing each other. Their ears learned the pattern long before their brains could name it. The road became a rhythm lab. Here's why driving loves polyrhythms. Driving itself is a layered rhythm. Your hands maintain steering rhythm. Your foot manages acceleration. Your eyes scan traffic patterns. Your brain anticipates movement. Multiple timing systems operating simultaneously. Exactly like polyrhythms. That's why groove-based music feels natural while driving. The brain locks onto one pulse while noticing another. Your body synchronizes motion with sound. The driver becomes part of the rhythm system. The dashboard remembered the lesson. Let's take a simple test. Let's try something. Tap your steering wheel 3 times. Now tap your foot twice. 3 taps. 2 taps. You just played a 3 to 2 polyrhythm. Congratulations. you passed the math test. Without knowing it, millions of Americans learned this rhythmic language while commuting. Not in classrooms, not from textbooks, but from repetition through car speakers. Note, 3-2 is not the only polyrhythm. Other examples, 6-4, 8-5, 16-9. The permeations are infinite, but the concept is the same. Here's the science behind the groove. Scientists studying music and cognition have discovered something fascinating. The brain loves predictable complexity, not chaos, not simplicity, but patterns that repeat while shifting slightly. Polyrhythm does exactly that. It gives the brain multiple time references. The listener follows one pattern while anticipating another. That anticipation releases dopamine. The result? Groove. The feeling that music is moving you forward, just like driving. Now you see, pop music solves the equation. Modern pop music is built around these layered timing systems. Listen to soul bass lines locking with drums, funk guitar accents landing between beats, hip-hop producers layering kick, snare, and samples, electronic dance music stacking rhythmic loops. All of it traces back to the same mathematical principle. Multiple rhythmic trains moving across the same track, meeting again at the crossing. Let's look at the cultural equation. The equation looks like this: African polyrhythm, American mobility, teenage dashboard listening equals modern pop music. The classroom wasn't a university, it was the automobile, and the curriculum was groove. Here's the echoes and footprints insight. The beat route is clear. West African rhythm systems cross the Atlantic, blend with blues and gospel, enter radio towers, travel through dashboard speakers, and train millions of American ears. The automobile didn't invent rhythm, but it became the classroom where America learned how rhythm works, the math and science of groove. So the next time you hear a great groove, remember the 2 trains: 3 beats, 2 beats, different speeds, same crossing. Polyrhythm isn't complicated. It's simply motion meeting motion. And in the classroom of the American highway, that lesson played again and again until everyone passed the test. The dashboard remembered, and the beat remembers too. So now we understand the equation: 2 rhythms, 2 motions, 1 groove. But something interesting happened once Americans learned that rhythm. The beat didn't stay on the highway. It kept traveling across oceans, across continents, across cultures. Next time on Dashboard Chalkboard, we open the map. From Caribbean rhythms to Latin grooves, to European dance floors, to African cities, to soul and back again. Because once mobility met technology, the classroom expanded, the highway became the planet, and the beat routes went global. The classroom may close, but the highway stays open, and the beat remembers. The beat is the history.